and engineering at Flexport. And Flexport is a freight forwarder, which basically means we're a travel agent for shipping containers, like the one over there. Instead of like human travel agents, it's more like a bunch of JavaScript deciding where things go, but close enough. And so anyway, what I'm going to talk about today is code splitting. So Brian gave me a great setup here, and now you all care about reducing the size of your JavaScript payload. So that's really awesome. We'll go into it in a little bit of detail. First, some context though. So a lot of this talk comes from some of the work that we've done at Flexport. And the reason that we needed to do that work is because apparently business is good, and we've been able to hire a bunch of engineers. And the problem is all those engineers keep writing tons of JavaScript. And so as our amount of engineers increases, so does the size of our application. Probably like a lot of you here, we use Webpack, and so when you're building your application in Webpack, you have across the top all of the stuff that makes up your app, and then you kind of have this funnel effect where you give it to Webpack, and Webpack like shoves it all together into one big file, one big bundle. And so, you know, in the early days of Flexport, you know, that was fine. It wasn't 10 kilobytes, Brian. That's pretty ambitious, I think. It'd be awesome for us to get there, but it was, you know, 100 kilobytes or 200. But then it got to like 400, 800, and then it started being measured in megabytes, which was getting really out of control. I want to emphasize one point that Brian made, and this quote from Adi Osmani: JavaScript is the most expensive part of your site. So it's not just about the network speed. You know, users on slow network connections, obviously it takes longer to download a larger file. But as Brian said, if you have a 100 kilobyte image file and 100 kilobyte JavaScript is in no way equal to that, because JavaScript needs to be parsed and then compiled and executed. And you know, while the execution time might be dependent upon how good code you write, the parse time is pretty much proportional to the size of your payload. So in our application, for example, you know, it was taking, you know, hundreds of milliseconds or even seconds just before the browser could even begin to run the JavaScript. And so at page initialization time, that shows up as kind of like a big pause where the browser can't do anything. So it's really important to lower the size of your JavaScript, even if your users are on fast network connections. Another reason that this was important for us is CICD, or continuous integration, continuous delivery. So all those engineers at Flexport that are writing all that JavaScript, they like to ship it to production and get user feedback really quickly. And so our users love that because we deploy every 20 minutes. So every 20 minutes, they get new features or bugs, depending on who wrote it. Just kidding, we don't write bugs. But the problem with that is that because they get new features every 20 minutes they also get the pleasure of having their browser cache wiped because that big bundle gets replaced with another one. So code splitting is really important if you're doing CI/CD as well. And so the first form of code splitting that I'm going to talk about, it's pretty basic, and maybe some of you are already doing it. It doesn't actually aim to reduce the size of the JavaScript payload, but instead we split it into two different files. One file, vendor, which you should aim to have all of your third-party dependencies like React and Lodash and LeftPad or whatever you need to run your application. You're probably not updating those dependencies very often. So if you put them in a separate bundle, the browser will cache that. And when you're shipping new features in your app bundle or changing the colors of buttons or whatever it is you're doing, the users will be downloading the new app bundle, but the vendor bundle will still be cached. And that cache will be, you know, hopefully that cache lasts for a long time if you've set it up correctly. And so effectively, users are downloading just the application, not all the dependencies. The second and, you know, thereafter times that they visit the site. So to set this up, it's changed a little bit in Webpack 4, and Webpack 4 actually will do this by default now. But if you have a reasonably large application, I'd recommend you sort of audit what's going into that, because I think by default, everything in node modules ends up there. And we all know that your node modules directory can get quite large. So what we do is we have a whitelist of files that we know are used on every page, and we tell Webpack to put them in the vendor bundle. But that's just kind of the basics. And the second form of code splitting that I want to talk about is actually my favorite. So a lot of the stuff in Brian's talk, some of the things you need to sort of, like pay attention to, and maybe it changes the way you write code or changes how you build your application. But other ones, like broadly, if you're using it for static assets, you basically just switch on and then forget that it exists, because it's just going to keep working thereafter. And so this form of code splitting that I'm going to discuss, it's my favorite because it matches with that. Once you set it up, you don't have to change anything about the way you write your application, and you just enjoy the benefits forever afterwards. And at Flexport, we had our front-end infrastructure team do this, and none of the product engineers had to care, but they still got to enjoy the benefits. And so this is route-based code splitting. So probably your application has a bunch of different URLs to which you can go to access it. What route-based code splitting does is tell Webpack to build a separate bundle for every URL, really. And so what you do is you have your vendor bundle, but then you have an application bundle, which probably is sort of like, maybe it's the root path in your app or the home page. But then, like, say you have a profile page. When a user's going to the home page or the root, you don't want them to download all the dependencies of the profile page. So by telling Webpack to split by route, you essentially have a number of different entry points into your application, and each one of those bundles has all of the transitive dependencies that just that page needs. And so the way you do this, or the way we do it, is basically to switch from this static import on the left, where you're just statically importing profile page and then rendering it. I mean, obviously this is not a feature-complete router, but probably you're using a bunch of different routing systems. Basically what you do is you go to your router or your navigation module or whatever centralized part in your code base you have for navigating between pages, and you change that implementation so that instead of statically importing all of your different pages, you dynamically import them with, you can see it in the handle navigate function. And so what that does is tell Webpack this is a split point, and so when Webpack's building, it won't go to profile page and pull in all the dependencies. It will just build this file with kind of like a reference to that, and then at runtime, the dynamic import function it returns a promise, and so you just run it, and then when the code loads, you then render the new page. And so this is some example code that won't work, but hopefully gets the idea across about how to set that up. And so that's really nice because your JavaScript bundles will decrease in size a lot if you have a large application. This example from Flexport actually demonstrates it. Hopefully you can see it. But on the left here, we have the size of our JavaScript pre-code splitting. And you can see that gradient is terrifying, right? Like every week, people write more and more code, and it just keeps climbing. And so, people are making a really complicated profile page, but the home page just keeps getting slower and slower and slower because people add code to the profile page. And then after code splitting, we end up with tons and tons of different bundles, but they're all pretty small, with a few exceptions. There's about 4 or so files that are really still quite large. If you can't see the y-axis, they're about half a meg. So they definitely need more work. But you can see that this thing dropped the amount of JavaScript payload that we needed, like by 3x or so. So that was really cool. And yeah, importantly, only like a small amount of, like, you just have to do one project to implement this, and then all of your product engineers don't really have to care about it, because when they navigate via URL, they'll get the benefit. But you can go deeper than that, actually, with code splitting. And this next kind of code splitting is it's called component-based code splitting. And there's a really cool library by Jamie Kyle called React Loadable, which makes it really easy to set this up. And basically the idea here is you have this red one on the left, which is route-based code splitting. And so you can see there at the root you've got probably the home page, and then each one of those columns is one of the URLs in your application. And you can see that Webpack is building a bundle that contains all of the dependencies there. And component-based code splitting is actually kind of nice because it takes the idea that perhaps some of those dependencies don't need to be on the page at page load time. Maybe they are in a modal, or maybe they're behind a tab control, or maybe they're just a drop-down, or a hover card, or a tooltip. There's tons of different kinds of UIs that only really need to be there if the user does something. And so what you do is you do have to change the way you code a little bit and avoid statically importing things. But this React Loadable library will help you out. And then you'll end up with even more bundles as we have on the right here. So what you end up with here is, you can see we've got a modal bundle, a hover card bundle, tooltip bundle, and what that does is reduce the size of all of the route-based bundles, but it also reduces duplication that you end up in those route-based bundles, because this picture on the left is actually a little bit of a lie. You could imagine that maybe the profile page uses a modal, and you have some third-party library for displaying modals, maybe in portals or something like that. And then perhaps you've got a tasks page, and that also renders something in a modal. Well, the code for the modal will end up in both of those bundles. And so that means that red picture is a little bit inaccurate. This bit here and this bit here might actually be the same code. And so the browser's kind of wastefully re-downloading that code when you navigate. And so if you use component-based code splitting, the browser will only have to download that once. And then it also helps out with that cache invalidation problem that I mentioned earlier too. That's kind of those are the different types of code splitting that I think you should be aware of, and you should definitely do the route-based code splitting. The component-based code splitting is great too, as long as you want to learn how to do that and change the way you write your application a little bit. It's actually really easy, so you should definitely check out that React Loadable library. But you notice that some of the bundles that we have at Flexport are still really big, like these 4 or 5 at the top. And what you have to do there, the problem there is that they just have a lot of dependencies, and it's not obvious that all those dependencies are actually needed at initialization time, at page page load time. And so what you can do, which does take work, is do a little bit of dependency trimming. So what I mean by this is, oops. So what I mean by this is, and so this is Flexport here. This is an internal application that we use to move those shipping containers around. What you can do is use this really nifty thing built into Chrome called the code coverage window. So if you open the developer tools, and then if you go to the network tab, which is right here, and then if you hit escape, you end up with this little console at the bottom. Well, if you click this little thing, you can then get the coverage window to appear. So it's kind of out of the way, but it's really useful. Once you do that, reload the page, and what this will do is it'll obviously reload the page, but it'll tell Chrome to annotate every line of code that you run while it's initializing, and then it gives you a really cool report at the bottom. So you can see here that we have 2.3 megabytes of unused bytes in the very first bundle, which is actually one of these route-based ones. And so if you then click it, you get this list here, this source code, and you can see the red means that it wasn't executed and the green means that it was. And so what you can do is literally just scroll through this and just see if it makes sense. So you can see here that this thing is really quite red. And so maybe I should look into that and figure out if this code actually needs to be there at initialization time. And so one thing to note though is that I think when the browser requires a lot of these files, some of it will appear green. You can see that the function definition part is green. That doesn't mean the function's being run, it just means the function's being declared. The body of the function is all red, so that means that code's not actually getting run. So if you do this, and then if I scroll up, I can see that this is this node module AG grid that we have in our code base. And so I should probably go investigate that and figure out, are there is that actually being used on this page? It doesn't look like it. So probably that's a point where I can go and add that React loadable library, or maybe instead of using the React loadable library, it's possible that this code is being included but not being executed, like it's dead code. And Webpack tree shaking is pretty good, but in our experience, when you have an app with multiple entry points, it doesn't work that great when you have files that have lots and lots of maybe utility functions in them, if those utility functions have different dependencies. So it's possible that some utility function depends on AG grid, and maybe we're not even running that, but we're using a utility function that exists in that same file. And so then that means that that function implicitly depends on AG grid when really we don't actually care about it, and we don't need it. So that's some stuff that you can do to try to hunt down opportunities to reduce your bundle size. And so that's all I have for you here today on code splitting. As a reminder, I work at Flexport, and we have a sponsors table over there. And obviously, as the graph indicated, we're kind of hiring right now. So if working on any of this stuff sounds interesting, come find me at the sponsors table or anywhere else later on, and we can talk about code splitting or any other type of front-end stuff. I love chatting about that stuff, so come hunt me down. Thanks, everyone.
All right, thanks, Desmond.